Take a look at an ice cube melting on a warm kitchen counter. It begins solid and slowly collapses into a puddle. If you move that puddle back into the freezer, it returns to its solid form. The water changed its appearance, but it never stopped being water. This is a physical change. Now compare that to what happens when you ignite a wooden match. The wood darkens, curls, and falls away as a pile of gray ash. No matter what you do to that ash, you can never turn it back into a piece of wood. The original material is gone. This is a chemical change. Everything in our world follows these two rules. Objects can undergo a temporary shift in appearance or a permanent transformation into something new. Look at the textbook cover here, specifically the connected spheres at the bottom. Since we can't see those tiny molecules with our eyes, how do we actually know when a permanent transformation has happened? While we can't see the atoms moving, chemical reactions leave behind visible physical signs that we can observe. We look for 4 specific signs: a change in the physical state of the material, a new color, a sudden release of heat, or the appearance of bubbles and gas. Witnessing one or more of these signs is how we prove a substance has altered its identity at the most basic level. Now that we know what to look for, let's test these signs against a real-world experiment. For our investigation, we're going to use a small strip of a material called magnesium ribbon. Before we begin, look at its properties. It is a tough, flexible metal with a bright, shiny silver surface. Think about what might happen if we take this solid metal and expose it to the intense heat of an open flame. As we watch the experiment, look closely for the 4 signs of a permanent change: state, color, temperature, and gas. We'll use metal tongs to hold the ribbon steady as the tip enters the hottest part of the fire. Within seconds, the metal ignites, creating a brilliant, blinding white flame that releases a massive amount of energy. This gives us our first major sign of a reaction, an immediate and extreme shift in temperature and light. Unlike a pot of water simply warming on a stove, the magnesium's internal structure is actively breaking apart to release this energy. Once the light finally dies down, we can examine the remains of our experiment. The tough metal ribbon is gone. In its place is a dull white powder that crumbles and falls into the dish below. Let's look at the signs. We see a change in state from a hard metal to a brittle ash, and a change in color from silver to white. Because we see multiple permanent changes happening at once, we know the magnesium has undergone a complete chemical reaction. Since matter doesn't disappear, we have to ask, what did that shiny silver metal actually become? This shows the magnesium atoms packed together, surrounded by floating oxygen molecules. The fire's heat forced these atoms to break old bonds and lock into place in a brand new configuration. This new, permanent substance is called magnesium oxide. Every chemical reaction is simply the universe rearranging its invisible building blocks to create a substance that didn't exist before. These molecular reshuffles aren't just for science labs. They are happening all around you every day. You can see it when a bicycle frame turns orange with rust, when fireworks pop in the sky, or even when liquid batter rises and turns into a solid cake in the oven. You now have the scientific tools to recognize these transformations whenever they occur in your life. The world is constantly reinventing itself at the molecular level, and now you know exactly how to see it happen.